Hi, my name is Christy Manning. I've had the honor of working with this research team for 2 semesters now as a graduate research assistant. This research is very exciting to me because it's applied directly to industry. You're looking at an erosion control research plot. This is an 8-foot wide by 40-foot long compacted plot of basically soil that we test different erosion control products on. We're able to find out interesting information that you're not able to find out from the manufacturer, as well as be able to verify manufacturer standards as well. So this is exciting to me because it's funded by the Alabama Department of Transportation. They're very interested in erosion performance. You've probably seen scenarios driving down the side of the road where erosion could occur. You know, the soil is very sloped from the roads. There's ditches, there's sometimes embankments. And if there's one place we don't want erosion, it's on our roads. This is also very useful in construction as well. Construction activities disturb a ton of soil, and they're actually required to prepare an erosion control plan by the EPA. So discovering best practices through this research and having them applied directly to industry standards helps everyone from an environmental as well as a financial standpoint. In addition, I just really like construction, so it's pretty exciting to me. So on this plot, we measure when we put down erosion control products. As you'll see in a moment, we measure, we simulate storms, and we measure both the performance in terms of sediment loss and in terms of runoff, and in terms of the quality of the runoff that comes off the plot as well. As you can imagine, this is pretty labor intensive, redressing the slope, compacting it, doing all the analysis. So we have a team of undergraduates that helps us out that we hire each semester. So there's some really interesting things about this setup that are pretty unique to our site. This is hopefully will be certified by the ASTM as the second only standardized erosion control testing plot in the country. But this kind of goes above and beyond that standard in some interesting ways. One is that you see the sprinkler risers over here. Of course, that's what distributes the water droplets. But right beneath those, you see a little circular guy. Those are solenoid valves. So those just turn the flow on and off from a remote electrical place. So most of these setups just have a little valve. A lot of the bench scale setups just have little valves and stuff, but the electrical is something that makes it really convenient to work with and just really nice. Another thing is we have, you see the black curtains everywhere with the big posts, those are wind curtains. The standard requires that testing only be performed when the wind is 1 mile an hour or less. So this allows us just to increase capacity of testing to test when there's 2, 3, 4 mile an hour gusts, which really helps us just move testing forward. One thing I would recommend is have an undergraduate research experience, whether just working informally with a mentor or having a formal fellowship or a formal paid opportunity or whatever the case may be. I had an undergraduate research experience in partly with the geotech department and partly with the chemical engineering department. And my experience led me to believe that I enjoyed research, but not necessarily that avenue. One thing that makes me really excited about this research is it's very practical. It's applied directly to industry, directly to the DOT, and I think the results are really relevant for the construction world as well as the environmental water world as well, which are 2 things that are very important to me. So just kind of having the opportunity to explore things that may be important to you, may not be important, as well as aspects of research that are and are not exciting, and whether research might be for you or not is something I would recommend.